Welcome to the IUPI Well Design Process module in the reservoir development phase of the E&P life cycle. Before beginning this course, you should have an understanding of the general configuration of a well. Be familiar with the reasons for drilling a well. Know about basic geological structures and pore pressures. This module will discuss the process involved in designing a well. At the end of this module, you should be able to describe the general configuration of a well. Identify the criteria used in selection of casing setting depths, sizes, weights, and grades. Explain the functions and properties of a drilling fluid. Describe the types of drilling fluids used and the circumstances in which each type is used. Explain why deviated wells are drilled. Describe typical deviated well patterns. Demonstrate familiarity with the terminology associated with deviated well patterns. Identify the constraints in achieving the trajectory required in a deviated well. Designing a well is a complicated process, and every well is carefully planned so that it will be safe, cost-efficient, and productive. The drilling engineer is responsible for designing the well based on the following information: the objective of the well, the depth and location of the target, the geological cross-section, and the pressure of the fluid in the formation pores. Three important aspects of the well that are planned during the design process are the configuration of the casing, the steel pipe which lines the well, the drilling fluid, a liquid that helps keep the well clean and prevents the well from flowing during drilling, and the direction in which the well is drilled. This module will cover each of these three factors in detail. Once the well has been designed, a drilling program is written. A drilling program gives instructions to the various parties involved in drilling the well on how to perform their operations. The drilling program is used to select the appropriate tools to drill the well, order the required capital equipment, such as casing, and to schedule the operations. A typical drilling program will contain the following information: the drilling rig to be used to drill the well, the proposed location for the drilling rig, the casing sizes, specifications, and setting depths, drilling fluid specifications, directional drilling information, and well control equipment and procedures. Virtually every well that is drilled requires casing and cement. Casing is steel pipe that lines the borehole after it has been drilled. The casing prevents the hole from caving in and seals off pressures in formations. To do this job effectively, though, cement has to be placed in the annular gap between the borehole and the casing. Casing comes to the rig in 40-foot-long sections called joints. There are many different diameters and strengths of casing available. Each joint of casing has a screw-threaded connection on either end. The individual joints of casing are screwed together. Each section of hole is drilled, and then the casing string is run. After this, the casing string is cemented into place. Once the cement has set, the next section of hole is drilled. It is almost never possible for the drilling contractor to begin drilling at the surface and go all the way to the total depth of the well in one step. A well will usually require several strings of casing before final depth is reached. These strings are called conductor casing, surface casing, intermediate casing, and production casing. As the crew drills the well deeper, the size of the hole and the size of the casing gets smaller in diameter. Each string of casing must be carefully designed to withstand the anticipated loads to which it will be exposed during installation, during the process of drilling the next hole section, and during the production from the well. These loads depend on parameters such as the types of formation to be drilled, the formation pore pressures, the formation fracture pressures, and the nature of the fluids that will be encountered in the formations. The designer must also bear in mind the availability of different casing types, any operational problems in running the casing string into the borehole, and the costs of the casing. Financial considerations are particularly important, since the casing costs can take up to 30% of the total cost of drilling the well. The casing strings are needed for a variety of reasons. Formations near the surface tend to crumble and cave in easily, so conductor casing prevents cave-ins. Conductor casing can be as large as 36 inches, almost a meter in diameter. Formations near the surface may also contain fresh water that could be contaminated by the drilling mud. So surface casing protects freshwater zones. Surface casing is relatively large, say 20 inches or 500 millimeters in diameter, or even more. The surface casing can be set at hundreds to thousands of feet deep. Deeper formations can sometimes be troublesome. They can collapse into the wellbore. Drilling fluids can flow into them, resulting in lost circulation, or fluids can flow from them into the wellbore. Once drilled, they need to be sealed off to prevent problems in drilling the deeper portions of the well. Intermediate casing seals off troublesome zones. Intermediate casing is typically about 14 inches or 350 millimeters in diameter. Sometimes, deep wells require more than one intermediate casing string. Finally, once the producing zone is drilled, production casing is run. Production casing is about 8 to 10 inches, or 200 to 250 millimeters in diameter. The operator usually perforates or puts holes in this casing when the well is completed and ready to produce. Oil and gas flow into the well through the perforations. Sometimes liners are run into the well instead of casing. A liner is a short string of casing used to case the smaller open hole section below an existing casing string in the hole. It's just like casing, except that a liner does not run all the way to the surface. Instead, it's hung from the bottom of a previously run casing or liner string using a special piece of equipment called a liner hanger. Using liners saves money since they do not extend to the surface. Drilling fluid, or drilling mud as many people call it, is a vital element of the rotary drilling process. Although air, gas, and liquids can be used to drill a well, the most common are liquids. Muds can be either water-based muds or oil-based muds. In water-based muds, clay and other additives are mixed into the water to give the mud desirable properties. The two most important functions of drilling fluid are to transport cuttings from the wellbore and to prevent formation fluids from flowing into the wellbore. Drilling fluid is also used to maintain wellbore stability and cool and lubricate the bit. The drilling fluid must be selected or designed so that the physical and chemical properties of the fluid allow these functions to be fulfilled. However, when selecting the fluid, consideration must also be given to the environmental impact of using the fluid, the cost of the fluid,